So in the same way, I think we should start humans that way. So guess what you're going to get a lot of in this course? What? Sorry, an answer. You're going to get a lot of economics. You're going to get a lot of sociology. You're going to get a lot of anthropology, history, all the other broader fields that predict the behavior of humans in a group. You get a lot of that because it's going to be like, okay, in the aggregate, this is what happens. Now can I use that to sort of then go, what is an individual going to do? That's where we're going to start. So I'm going to argue that even if I cannot say what an individual will do, that is, even if I can't say what Byron or Heather is going to do, I gain some predictive value if I know that one group, for example, males, behaves differently than another group. Even if I can't predict that person, it is still useful to know that in the aggregate, this is what tends to happen. Any questions about this perspective? It's quite different. It's not how we normally think of this. It's not the view we normally take. I'm out of soda. And I'm very thirsty. All right. So we're going to call this view needs a name. We're going to call this the atomistic perspective. And whenever I say atomistic perspective, all I mean is let's first think of the group. And there's going to be some tools that we're going to need to know and that we're going to explore in this course. There are going to be some tools that's going to help us out with the atomistic perspective. And through the rest of today and on Monday, I'm going to give you some of these conceptual tools that help the atomistic perspective work. But whenever I say atomistic perspective, it means think about the group and then work in. Other fields start that way. Other fields often start with the general first and then move to the specific. This is not something unique to this course. So for example, many fields first go, what is relatively the case, and then they go to quantify what is absolutely the case. So many fields first start with the relative situation and then narrow it down to an absolute. So if you look at the history of geology, geologists, after, who we want to give credit for this? Lyle. So I want to give credit for this, Charles Lyle. Since I know this is being filmed, that's as good a person as any. Let's see, James Hutton deserves some credit for this. These are just geologists who helped get us on our current track. What they started realizing is the Earth seems to be relatively old. They looked at things like so let's give some things here. Some of the examples they used. This is near Swan Bridge up the road here in Alabama. I just love the layering that you can see here. But what geologists like a guy named Steno, a guy named James Hutton did is they all sort of went and they said, look at all these layers, all these individual layers. And they said, how long would it take for one layer to form? And they're like, okay, if you want to sort of imagine a layer of rock and it forming, sort of imagine how if you just sort of leave this room alone and a little bit of dust starts collecting on stuff, right? How long would it take for that dust to get a little bit thicker, a little bit thicker, a little bit thicker? Or if you just leave a piece of paper outside in your lawn or make it metal so it'll stay around for a while, and just stick it right on top of your grass, and over time a little bit of dirt will cover it, a little bit more. And you go, okay, to form one layer is going to take a lot of time. Well, how long would it take to form lots of layers? A lot of time. And what they did is they said, the Earth has to be really old to get all of these layers. So they said it's relatively old. And then the next question was, if it's old, how first established the relative, then the absolute. They said the Earth is relatively old, and then we developed techniques to discover the absolute. What are some of the ways that we can start doing the relative? One of the things you should have learned from statistics, and if you haven't had statistics yet, you should learn it when you take it. There is a distribution that we see over and over and over in the world called a bell curve. It's called the bell curve because it kind of looks like a bell. Right? You can imagine like, ding dong, ding, that's a little bell. Looks like a bell curve. And there are several characteristics of the bell curve that we really need to know. So this axis here could be height. This axis here could be weight. This axis here could be IQ. This axis here could be socialness. This axis here could be number of sexual partners. This axis here could be, I'm just trying to think of variables it could be. This axis here could be number of friends. Doesn't matter what we're going to put down here, we're going to find two characteristics of this curve. One, there's a central tendency. Every bell curve has a central tendency. And what this means here is, in statistics, it's usually the mean, in fact almost exclusively the mean of the curve. We take all of the numbers together, add them, and divide by the total, and so we find whatever the mean property is. So, let's see. Anyone have clickers today? Yeah. All right. So we're gonna have to do a little more math. I'm not gonna do it in terms of math. But let's go. If I were to go, how many courses are you taking this semester? So if I were to go A, B, C, D, E, and you're taking at least one because you're in here. 2, 3, 4, 5. So if I were to go, how many courses are you taking? So you can see how the clickers work. How many courses are you taking this semester? Let's go 5, 4, 3, 2, 1. I hope this math is not going to be too onerous. So it's really 17. That can be an even number to divide by. All right. So really, is one person only taking this course also? All right. So we got 1 plus, let's see, 11 people are taking 4 courses, so 44. And 5 people are taking 5 courses, 25, 69, 70 divided by 17. I don't really care what that number actually comes down to. What's it going to be? 70 divided by 7. If anyone wants to rip out a phone real fast and help me out here. Well, I turned it off. I got it, I booted it up, man.
4.117.
All right, so 4.11. So what I would do here, if I've done my math right, and I'm sure if I haven't, the people at home who have way more time than I do are going to correct me. That's totally fine. You don't get extra credit for it. All right, so I would go, okay, there's some sort of shape of this curve, and the mean of this curve is at 4.11. All right. Well, that's not the only thing that defines this curve. There's also a spread of the scores that define this curve. I'm not going to worry about figuring out the standard deviation now. That's not the point of this course. But the standard deviation is the spread around the mean of the, the spread around the mean. There's nothing else to finish that sentence with. Now, so just looking at the results from this class, we see that the curve probably isn't really widespread out. Most of the people in this curve, right, we got 4 and 5, we got that one person down here, but if we have the mean at here, so here's 4.1, here's 4, here's 5, it probably looks something more like that, right? Almost everyone is near the mean for this. But if we had it completely spread out, instead of having a bell curve like that, it might look like that, where there's a lot of spread. What is the spread? What information does that tell me? What does the spread tell me?
There's a lot of variability.
It tells me a lot of variability. So you can think of it this way. Let's say that I'm asked, and someone goes, Dr. Robinson, how many classes do your students take a semester? If there's a very narrow amount of variability, how accurate can I predict?
Decently accurate.
Decently accurate. But if there's a lot of spread, even if the mean's at 4 point whatever, if there's a lot of spread, how accurate is my prediction going to be? Not very much. What I need to know from a data set is the mean, if I can get it, and I need to know this spread. I need to know how spread out these numbers are in the population. Every data set is going to have, if we can do an average on it, it's going to have the mean and standard deviation. So that's the mean and standard deviation. These allow me to make conclusions about the population. So I'll give you a nice standard bell curve. This is, if you take statistics, this is a normalized bell curve. And what I can know here is, okay, here's my mean right there. Smack here at in this particular case, has been normalized down to 0. All right, if I do the appropriate analyses on my bell curve, not only do I know where the mean is, but I know roughly what percentage of people fall on both sides of the mean. I know that roughly 68% of the people fall within one standard deviation of the mean, one standard unit from the mean. Does that help me predict the group's behavior? Yeah. I know that nearly, let's just for the sake of this class go, 2/3 of people, I realize that's not technically accurate and some people get really cranky about precise numbers. I'm not one of those people. I look at this and go, roughly 2/3 of people fall within one standard deviation of the mean. So if someone says to me, Dr. Robinson, what's the average IQ in your population? I would say, well, the average IQ is 100, but 2/3 of people fall between 85 and 115. Is that useful information? Yes. I mean, I see that as extraordinarily useful because I go, if I'm trying to think of general policies, general rules, general instructions, I need to keep in mind that most people have an IQ of 100 and 2/3 of them fall within 85 and 115. I think that's pretty useful information. And what we can do here, so we now also know that 2/3 of people, give or take, I know that's not precise, but also I know that the further that I get away from this mean, the fewer people. Roughly 14% of people have IQs between 70 and 85. 14% of the population have IQs between, did I do the math right here? Yeah, 70 and 85. Also, roughly 14% of the population have IQs between 115 and 130. All right, so you see if you can do some other stuff with it. So this is 50% of the population. So 50% of the population have IQs less than 100. Or 100 and less, technically. I shouldn't have added technically that because I know someone's going to just jump. This is really kind of nerve-wracking to be knowing that people are going to be able to film and go, you said technically, and I don't like to wager on that. What do I also know? 50% of people have IQs higher than 150. I'm sorry, higher than 100. That's useful information. And what we can do here is we can now put some terminology. In many ways, when we're going to talk about the cultural norm, in many ways we can think of this as, and this is not a technical definition, it is one that I think is useful, but we can say, in many ways, the first standard deviation sort of represents the norm of the group. The people within the first standard deviation represent the norm. So the norm of our group is an IQ of around 100. Or the IQ, if we could figure out the standard deviation of our class, we would say the norm for number of classes to take for a semester is 4.